There are a couple fairly straightforward formulas that I'd like to demonstrate, and one of these is the distance formula, and so we use it to calculate the distance between 2 points. And so here we're given the example, find the distance between the points 3, -4, and 6, 0. So the first point we can designate with coordinates x1, y1, and the second point we'll just have the coordinates x2, y2. And now we can just plug those coordinates into the distance formula. So we've got that d is equal to the square root of x2 minus x1 squared, so that's going to be 6 minus 3. So those are that's the difference in x coordinates, and square that, and add to that the difference squared for the y coordinates. So y2 is 0 minus y1, which is a -4. And those two negatives will cancel, but it doesn't matter because when we square that expression, it turns positive anyway. So we end up with the distance being the square root of 6 minus 3 is 3, and we square that, that's 9, plus 0 minus -4 becomes +4, but we square that, and that's equal to 16. And now we've got the square root of 25, which is just equal to 5. And so that's a fairly straightforward result, but we can think a little bit more in depth about what's happening here as we consider the distance between these points. So the first point is the point 3, -4, so 3 in the x direction, -4 in the y direction, and we'll plot a point here. And the second point is the point 6, 0, which we will plot over here. Next, we can draw a line segment between those 2 points. And the length of that segment we can actually calculate using the Pythagorean theorem. So there are 3 units between the 2 points in the x direction, and there are 4 units between the 2 points in the y direction. And we can see that as we use the distance formula that we are calculating the square root of those 2 squares. And so our formula that c, which is the hypotenuse, is equal to the square root of a squared plus b squared is going to apply here. That again, our x distance is 3 units, so we've got the square root of 3 squared, and our y distance is 4 units, so we've got 4 squared. And this is the same result as we had in our distance formula calculation. So there is a geometric interpretation that comes from this formula. The next formula we'll be looking at, which is also fairly straightforward, is the midpoint formula. And basically, we can calculate the midpoint between 2 other points on a line segment. And so that midpoint has x and y coordinates, and the x coordinate is given to be x1 plus x2 divided by 2. And when you add 2 numbers and divide by 2, you're actually taking the average of those 2 numbers. So the x coordinate is the average of x1 and x2, and the same is true of the y coordinate. So when we want to find the midpoint of these 2 points, 4, 3, and 2, -4, we'll find first an x coordinate. So we can say that x is equal to the sum of x1 plus x2, so our x coordinates are 4. And then our second x coordinate is 2. So that's x1 plus x2, divide that by 2, and we end up with 6 divided by 2, which is equal to 3. So that's our x coordinate, and we can do the same for the y. That y is going to be equal to the sum of the 2 y coordinates, 3 plus a -4, and dividing by 2, we end up with -1 in the numerator divided by 2, so that gives us -1/2. And so this is an ordered pair. It's the point 3, -1/2. And just like with distance, there is a geometric interpretation, so we can graph these 2 points. So the first point is 4 in the x direction, positive 3 in the y direction, gives us a point here. And the second point is 2, negative 4. And we can draw a line segment in between these 2 points. And now if we look at the midpoint that we calculated, 3, negative a half, 3 in the x direction and negative a half in the y direction, we get a point that lands here on that line segment. And as you can see, that point appears to fall roughly halfway between the 2 original points that we started with. So again, this is a graphic representation of the calculated value that we got. The one caution that I would offer is that although these formulas are relatively simple, that they are sometimes confused with each other. So the first formula is the midpoint formula, where we have 2 coordinates, x and y, and each of these 2 coordinates is the average of the coordinates of the 2 points. The second formula is the distance formula. And here we're calculating the distance as the sum of the squares for the x difference and the y difference. And then the third formula is the slope formula. And here we're using the difference or the change in y divided by the difference or the change in x. And each of these 3 formulas uses 2 points, each having an x and a y coordinate, x1, y1, and then also for the second point, x2, y2. However, each of these 4 coordinates is put together slightly differently in each of the 3 formulas, so it's important to pay attention to those differences.